Welcome to our webinar. Today's session is on microservices. I'm your host, Ashish Shanker. I just wanted to cover a few housekeeping topics first before we get into the meat of it. So I just wanted to point out that this webinar is being recorded, and within 24 hours or so, we should be able to put it up on the Synerzip YouTube channel, and you guys will receive an email with a direct link to that webinar. We want to keep this very interactive, so if you have questions, anything at all, feel free to put it in the put it up through the chat. I'm monitoring the chat channel, and as it makes sense, I would bring up those questions for our presenter to answer. I'd also like to point out that the link to the next webinar is actually up. This is a very interesting session on how to prevent botnet attacks for people who are more of a security bent of mind, or even if you're looking to understand what botnets are all about. This is the right time with the recent spate of ransomware and so on. Is probably a good topic to cover. So with that, let's turn our attention to the topic at hand. And our presenter today is Anil Allewar. He lives and breathes microservices, and I'm happy to have him here. But one of the very profound takeaways that we've had about microservices is that microservices is a business transformation tool masquerading as a software engineering paradigm. To me, that's profound. In fact, if it ever becomes an internet meme or something, just remember you heard it here first. So with that, let me hand it over to Anil.
Hey, thanks, Ashish. Hi, good morning, everyone. It's so nice to have you all with us today. So let's get started. So I'll give you a brief introduction about me. I'm a director of engineering at Synerzip. I'm a technology evangelist and speaker. I love to learn about new things, try them out, see how they fit into different products that we're developing, and the entire software engineering paradigm. My core interests are cloud, enterprise, and mobile. I also kind of love to dabble in anything new that's on the horizon. All right, so let's now get into the meat of what we want to discuss, which is about microservices. So what we're going to discuss today is a very brief, like a 30,000 feet view of what microservices are. With that, we'll look into two use cases wherein we kind of have seen businesses transform the way that they function. We'll be calling those two use cases as breaking the monolith and fueling innovation. We'll look at the best practices and gotchas that we've seen while implementing microservices, and then we'll have an extended Q&A session at the end. Like Ashish said, please feel free to send in your questions as and when you feel they're appropriate. Ashish is monitoring the chat window, and we'll try to cover as much questions as we can. All right, so let's see what microservices are, right? So over the last 20 years or so, we've seen the software architecture has evolved. When we started out, we wrote a monolithic application. So we had a single application that used to do everything. In time, what happened was that almost all components kind of were very tightly coupled with each other, which led to what we typically call as a spaghetti architecture. To get around from that, we kind of then moved to a service-oriented architecture where we had which fostered loose coupling by dividing our system into more loosely to components that were loosely coupled with each other. But these components still were kind of they shared the business models typically. So if you needed to change one piece, that would impact almost everything else in place, or it would impact a couple of other pieces. So you had to be kind of you had to be careful about how you change them. So the latest buzzword that's come in is microservice. So what microservices does, it basically allows you to create and maintain your business functionality as individual services that share data through APIs. So that's how they do that. Now let's see what's the difference between a monolith and a microservice. So monolith typically starts off, for lack of it starts off as an elephant. It starts off as a small elephant. So over a period of time, it grows, and it becomes kind of this unwieldy beast. You would have, over a period of time, you would have cases wherein you would have your business matures, you get more users in. So the only way to then kind of provide scalability to increase the number of users that you could serve would be by replicating this monolith, which is okay, but then it's not very efficient because only some part of your monolith might need replication and at varying degree. So then let's come to what microservices are, right? So the best definition that I've liked about microservices is by Adrian Koftrad, who says microservices is a loosely coupled service-oriented architecture with bounded context, and we'll get to bounded context in a bit. But what it means is that our system is broken down into small independent services that you could scale up individually. So let's assume in this case we need to scale up service 1, you just add more copies of that. If service 2 needs more scaling, you just keep adding more copies of that. That's how we scale up microservices architecture. Each one can be scaled up individually. The crux of microservices is what we call as a bounded business context. So bounded business context is a core theme in domain-driven design. So essentially what it means is, let's say we have defined a deer as one of our business model, right? So we define a boundary around that. So anytime that the deer has to change, it changes within this defined boundary. But let's assume we introduce some part of other service there. So let's say you introduce half of the lawyer into this service, which means that anytime you wanted to kind of change anything related to deer, it would also change, it will impact how your other service has been defined. So with the bounded business context, so what happens is a lot of the time people get confused by the term micro. In microservices, we tend to think it's about size, it's about lines of code, but no, it's not. At its core, it's about kind of being able to say what is the scope or the responsibility. Your service should be able to do the should be able to follow the single responsibility principle. That's what it's about. Okay. All right, so
Anil,
sure.
Let's take a quick pause here because I'm already seeing a lot of questions sort of come in, and I encourage our attendees to keep sending more questions because making it interactive really makes it fun.
That makes it a lot of
fun. This is a topic that's a really hot topic today. So one of the questions that's come up is, how do you differentiate, I guess, between microservices and what we used to know as object-oriented design with self-contained components? And I think this is probably more related to SOA versus microservices, but I don't know if Anil, you have a take on this topic.
I'll try to kind of give a brief answer to that. I'm hoping that might be relevant. So object-oriented design is basically a way to decompose your business, you would say your business model, into individual classes that model them, right? But they don't form, they exist in isolation. So let's assume you have an order system, right? You have an order object, you might have an order item object, and a couple of other objects that you'll have a couple of other classes that save an order into the backend. You would have a couple of other classes that kind of marshal it and send it out to the front end. Now each of them, when you define them, segregate them, are objects, and their design is defined by the principles of object-oriented design. But that's individually they are not a service. So when you take all components, all these objects together and form a service, let's say an order service that basically does takes care of everything related to order and order item, that becomes a service. So that to me is a distinction between object-oriented design and microservice. So the other distinction is between a service-oriented architecture and microservices. To that, I mean, what I said earlier is that microservices is service-oriented architecture. You are taking service-oriented architecture. The only thing that I found significantly different is that with the previous service-oriented architecture, you didn't define on a bounded business context. You didn't have services that did one thing and did one thing well. Basically, kind of follow the Unix philosophy, right? So when you had to change something, you also had to change a couple of other things. So that's the crux. That's the basic difference between just a service-oriented architecture and microservices.
Yeah, so I think that's a very good point, and I do want to add a few more things here. That when you talk about object-oriented design, you're essentially talking in the context of a single application, and you could have a very well-defined object-oriented design where all the various objects talk to each other, but within the context of that application. But when it comes to microservices, you've sort of taken that application and exploded it across many processes, and so a lightweight way of communicating between these becomes important. And each of these pieces is object-oriented, or it could be functional programming or whatever it is. But microservices essentially worries about letting these different pieces live with each other, live autonomously off each other. So that way, one service is not dependent on the other thing up and running. And then it worries about how to let these components talk to each other in a distributed computing environment. So with that, over to you, Anil.
Thanks, Ashish. All right. So let's look at our first example of how we've seen a business transform itself. So the first use case is where one of our customer had a monolith. So monolith typically it has a lot more than what you just see. It has a lot more facets to it that you'd see, and that basically over a period of time leads to a number of problems, right? So the first problem that we saw was that it used to take a long amount of time for us to release new features. It used to take close to 4 to 6 months. We had competitors who were quicker, who were able to get to market with newer features that we were developing, but they were there first, so they had the beginner's advantage. When we had new people join on the team, they used to take 3-4 months just to get started. That impacted productivity. We had unintended side effects because if people change something in let's say module A and it's tightly coupled to a number of other modules, you wouldn't know how it interacts at runtime unless you kind of see that problem manifest itself, mostly in production. That's what it happened. And then because you had problems in production, you always had to do firefighting to ensure that we are able to contain them and keep the customers happy. We had obviously fear of release. Owing to all these factors, every time you do a release, you have side effects. You have to put in a lot of efforts to get things in order. Eventually, people kind of start fearing, oh, I need to do a release now, kind of way. So that's what happened. We had horizontal scaling issues because we had to kind of replicate the monolith every time. The other problem that we saw over a period of time was that recruitment became a problem because the monolith started in a set of technology that became outdated quickly in about 3-4 years, and then it was hard to find people who were more willing to work there. So how do we kind of go about kind of breaking this out and transforming ourselves, right? This is a typical use case that we've seen with about 50 to 60% of our customers. Most of them have products that are mature over a period of time, and they are looking at how do I now take it to the next level. how do we take care of this problem, right? So the first thing that we did was we looked at the different components that were there in the monolith to say, okay, what is it that we could chip off easily? So typically you will have third-party systems. If you have third-party integration, that's easiest to chip off. Or if you have like a front end and back end with very well demarcated layers, boundaries, then it might be easier to kind of segregate those out. So what we did over here was we took a well-defined part of it, we took that out, make that as a different microservice. What we also did was any new functionality that we developed, we kind of developed them as microservices. We did not add it to our monolith at all. So that's what, so it's an evolving process. We will keep doing that and try to chip away as much as we can from a monolith until it probably becomes as big as an individual service. So that's how we started on this journey. So let's look at what are the key takeaways, right? So what we found was that when we attempted microservices, it actually kind of it led us to transform how we view the business. It also triggered an organization change. And what I mean, to go into more details on that, let me just quote Klaus Schwab, who is the chairman of the World Economic Forum. He said that in the new world, it's not the big fish which eat the small fish, it's the fast fish which eats the slow fish. So agility and being able to respond to change is what is paramount for today's businesses, and microservices will trigger that organization change. So what we did was, instead of silos that we had of application developers, DBAs, product owners, we kind of then split them into cross-functional team, with each team kind of owning the whole functionality. So each team had development resources, they had QA, product owner, DBAs as needed. So you had everybody kind of working together, being able to talk each other, and then take decisions much faster. What we also realized is that it led to an organization that was continuously learning. It basically we were able to innovate and then build a business model that worked in the long run. We had a smaller agile team of developers that was innovative. It was nimble. They were able to embrace change and then move forward very fast. So one of the key things that we did, and I encourage anybody who wants to look into that, into kind of being able to kind of chip off the monolith and move to microservices, is you need to deliberate and discuss what are the benefits that you have versus what are the risks that you take with being able to move to moving to a distributed architecture. So you need to weigh on the benefits. You have to look at the cons and pros and then decide whether making that move to microservices architecture makes sense for you. The other problem that we kind of encountered when we started this was, how do we version contracts between services, right? So when we moved from a monolith to microservices, now you had a pace where each component, like each service as well as the monolith, were being developed at a different pace, and they were only compatible at certain versions. So how do we kind of ensure that the data that gets communicated across the API is something that is which both you would say backward compatible or forward compatible, or it's at least consumable by the service we need it. So with this, the first approach that we came up with was to kind of now transfer data only as XML with well-defined XSD, so that you can basically you could actually kind of validate that schema and see that the data kind of gets passed off correctly. So we now deploy only versions that play with each other, and then over a period of time, what we should kind of really do is move to what we call as consumer-driven contracts, and make our services both backward compatible and forward compatible as much as we can. That was something key that we discovered. The other thing that we realized was that we need to keep our monolith dormant. We don't need to add anything more to that unless it's something that's core to the monolith, and we can't really create that as a separate business functionality. What we also realized that when we move to a distributed world, each team develops at their own pace. So DevOps and automation are intrinsic to microservices. So I shall take a pause. Any more questions that we have?
Yes, Anil, looks like you saved your Mac from shutting down last minute.
Yeah, I did.
So there's a few more, I think, very interesting questions. And again, it's great to have this flow of questions. Encourage our audience to continue sending more questions. So one question that's come up is, given that you're talking about the fact that if you did microservices in your organization, it is going to lead to a business transformation. So the question really is, so from in your experience where you've seen microservices getting deployed, who's really driving microservices adoption? Is it executives knowing that they can transform their business, or is it sort of top-down kind of thing? Or is it more of developers essentially trying something and accidentally leading to business transformation? Or is it more of DevOps people trying to sort of make their world or give their world a bit more sanity?
Mostly what I've seen is that typically in kind of the monolith scenario, it comes top down. Because kind of what happens is over a period of time, the upper management sees the problems that they see from a business perspective. They see that we are not being able to respond to our competitors. We're not really being agile and getting there. So that's where the push now comes down to say how do we go ahead and ensure that we develop at a faster clip. We don't have a lot of issues when stuff goes into production. So that's where it comes down on. And then typically from a development perspective, what I've seen is typically developers are really happy to kind of try out something new. So once this idea comes to the developers, is how do we go about and then kind of ensure that the problems that we see our monolith go away and microservices is presented as an alternative. I've typically seen developers kind of jump onto that bandwagon because there's something for them which is really neat, newer things, something new to do, cool to do. So it gets adopted fairly quickly also in the developer community. That's how we've seen it.
All right.
All right, so let's move on to our second case. So over here, we kind of the problem statement was that we had a company that needed a culture of evolution. So they have a base product that works very well into their domain. But what happens is that base product needs a lot of supporting services. It needs a lot of ways you could make that core product a lot more useful. So what happens over here is we kind of built minimum viable products based on customer interaction and perceived planes, how they want more functionality. So we developed a minimum viable product. We solicited customer feedback and typical lean product model. We shut down, continue, or pivot them maybe based on the feedback. So we have lots of small products that are mostly independent, but over a period of time they can have common functionality. So we don't know at the start that we have autonomous products now, but eventually they might share some functionality. They might share billing, they might share, let's say, authorization from a central server or something to that effect. But we know that that's something that's going to happen. Each product is trying to address a unique problem. So it needs diverse tools and technology. So that's where so from the start, we're looking at this as a typical microservices problem, something that microservices does very well. So what we went ahead then is to go ahead and then have a solution where we didn't really go the traditional microservices route to say that, oh, each product is really built up and split into different services. What we did was we kind of then had our microservice architecture as an amalgamation of different products. Those products kind of acted as services. The only thing that we did here was to kind of maintain a cleaner separation right at the start. We segregated the UI and the backend into different services. So if you see here, you would have different services with different products, and you have them being split into a UI microservice and a web service microservice. And then you would, from a microservice architecture perspective, you also need a lot of supporting services. You need a config server so that you can kind of have a centralized configuration. You would need a registry discovery so that each service can basically discover where the other services are and then be able to communicate with them. So it follows all the components that a microservices architecture requires, but we just that instead of the services being individual products, because we're starting out small, each product by itself now becomes a service. So over a period of time, what will happen is we'll have common stuff that each service does, and that will get moved out into common services. We'll have glue code that enables our services to communicate with each other. And then kind of do stuff together, and then we'll see that each product, because it's autonomous, maintains its own state in the database or any persistent mechanism that it needs. And because this set of services are more or less common, what we have is we have an API gateway that basically you would say distributes traffic to each services separately, being able to do routing, security, and metering there. And because we use a common shared infrastructure, we use container orchestration. So we use Docker containers to deploy our components. Each services gets deployed in its own Docker component so that it can be scaled up elastically. And then we use container orchestration to be able to monitor our infrastructure, and then if services go down, they can be brought up automatically. So any questions on this? This is kind of a very typical microservice architecture. Microservices need a lot, because inherently it's a distributed system. It needs a lot of supporting components for us to be able to kind of get it to work together. So I'll just pause for a minute and see if you have any questions on this.
Yeah, so Anil, another question that's come up is, so let's say you have some application, it's a monolith or it's an MVP, whatever it is.
Right.
But how do you find out that you are now ready to take the microservices path, and why should you?
Right. So I mean that's a key takeaway that might we discuss later, but what we have found is that typically what happens is when a monolith gets too big, that's a typical use case where you would want to then start breaking that into microservices. If you have problems trying to kind of get features to market quickly, that's where that's the first pointer to look at. Say, okay, am I being too slow now? And then take a look into into your system and see, okay, are we ready now to kind of really move to break this down and then move to a more distributed system that we are able to develop parallelly, have multiple teams develop it concurrently, so your features get deployed to market faster, and then you'll have if you have scalability issues, then you're able to scale them separately. So that's typically that point where businesses should start looking. If they kind of start seeing this problem, they should look into their product and then kind of take a hard look to say, okay, if I have these problems, is that something that microservices can solve for me? And then take that. Like I said, you weigh the pros and cons and then take that route.
Okay, and then another question is more around how do microservices actually share their data? So are these services, and I know we're trying to structure them in a way that they're loosely coupled and so on, but wherever there is a data dependency between two microservices, how do you make sure that the most current authoritative data is available to both of them? Are you essentially implying that both microservices essentially hit the same database, and hence that database becomes a bottleneck? Or are you saying each of these services have their own data stores that basically keep in sync through some syncing and caching mechanism?
Right. So typically when we do microservices, one of the founding principles is that they should have exclusive state, right? So what means that each microservices is responsible for maintaining its own data and then persisting it. Now with respect to where do we persist that data, there are two use cases to go about that, right? If you have a well-contained service that has enough set of data, they could have their own data store. So each microservice kind of maintains its own data and then shares that data over the data API. The question that I obviously get over here is, how do I kind of ensure that if I have let's say a user microservice, and the user microservice gives me a user ID, how do I ensure that it's consistent with what's there, right? So I think with microservices we will have to embrace what is called as eventual consistency, right? So you could have, so what we are assuming over is that when the user sends me a user ID, I assume that's a valid user ID, and your other service can just take that user ID as a point and then use that to basically store its data and then link it. So when you have to kind of take that or collate that data together, you get the user data. So once you get the user data from the user ID, you just assume that based on the user ID, your service would have that data. So that works best in a microservices paradigm because you have exclusive states. I've seen use cases where people share a data model and they share a same persistent store. That works in most cases wherein you would have you have smaller services and only let's say 2 or 3 of them are sharing the same data store. But as you start getting like hundreds and 200s, hundreds and more of microservices, that becomes untenable. So my suggestion would be to keep exclusive state and as much as you can kind of segregate your data into different data stores.
Okay, and then another question is more around performance. So would it be fair to say that when you move from monolith to microservices, there is a performance overhead? And then if it is, then how do you make sure you manage this overhead? And if you say there is no overhead or actually performance improves, then maybe talk a little bit about how that would come about.
Okay. So when we talk about performance, there are two aspects to that, right? So when you take a monolith and then you're doing everything there, obviously you're assuming that everything is local, but then what happens is memory and CPU is a shared resource, right? And it can only scale so much vertically over there. And then when you move to microservices, obviously each service is smaller, it has a smaller footprint. So there are obviously, like I said, there are trade-offs, and the only way to kind of being able to objectively measure it would be to take measurements and see that. What I have seen is that when you basically remove that, you make those transactions smaller and smaller, the individual processing time for each services decreases rapidly. So the time that you that you would have here that gets added here is marshalling and unmarshalling of data that gets passed around. So if you use a data format like JSON, what I've seen is that microservices actually, the measurements that we did were a lot better off because you could scale them up more easily, and the transaction boundaries were smaller. So you had processes being that request getting completed faster. And then if you use today's marshal laws, let's say if you use JSON as an example, it's a lot quicker to marshal and unmarshal that rather than kind of so what I have seen is that from performance perspective, we've typically seen microservices perform better because you just for the fact that you have smaller requests, your requests get over a lot quickly, and then you're able to scale that out individually. So that's kind of the
Yeah.
short answer there.
Yeah, so I think that's a good point. And the way I understand it is essentially microservices opens you up for infinite scale. And each component or each distributed element may have a little bit of performance hit, if at all. But because you're able to scale up, both on the X, Y, and Z axes of scaling, because you're able to scale up that well, it will basically lead to a better performance system overall. So I don't know if you think that might be.
That's definitely an aspect. Like, so if you look at the scale cube, like you said, so you need to be able to scale up at least along 2 axes to scale very efficiently. So the x-axis where is you do horizontal scaling by replicating your system, and then the y-axis is where you basically break down your system into functional components. So with microservices you get both x-axis and y-axis scalability, and that's definitely what improves it. The other part that people that we also need to look at is what with microservices there are two different patterns. There are synchronous microservices where you basically call a microservice, wait for it to return your JSON, and then you kind of make the next call. The other pattern that I've seen coming up and that's becoming more popular is what we call as reactive microservices. So over here, instead of kind of making a call and waiting for the response, it follows a typical asynchronous communication. You make the request and you come back, and then you wait for response on an asynchronous communication channel like a queue or an actor. So basically we're running an event loop, and this event loop basically takes further kind of care of managing a problem. It makes you a lot more performant because now you're reacting to events, and then your threads are not blocked in technical.
Right. And the performance in the context of microservices, this is a very deep topic, and by itself it could be a topic of a webinar. But another aspect to consider is that essentially microservices is a way of reducing service outage. So if you had a monolith and something failed in that monolith, it can crash the whole application. But in the case of microservices, let's say a subsystem failed, and that subsystem is used only by a very small group of your users, then the rest of the user base will not experience any outage at all. And when we talk of performance, you have to also account for uptime as a parameter in that performance. So the whole performance idea is not just about round trip to databases or round trip responses or number of concurrent users and so on, but it is also about system uptime. So with that, let me also.
That's a great point.
Yeah, so let me quickly cover more questions coming in, and this is great. This is a great conversation, and I can see that our audience have been grappling with this microservices topic. They're looking at the kind of question I'm seeing here. So another question
it's a simple concept, but it's difficult to implement. I would say that.
Yeah, absolutely. So another question that's come up is, if I already knew about microservices, I knew how to deploy them, so leaving the skills aside, if I were to be building a new application from scratch, why would I not do microservices, from the get-go? Why do I need to wait for a monolith to emerge?
Okay. So what I've seen over a period of time is that typically when you start building a system, you're not attributed for complexity of the system. So as the system evolves, you basically your model evolves, and then you kind of realize what your context are, what your business context are. So it's not something that really upfront. So for me, the other part of it is, let's say if you are a startup, right, and you're taking your idea to people. If you start building microservices from the start, it adds a lot of operational overhead in terms of the way you deploy the stuff. So for each developer who has to really kind of test his system, he has to deploy the whole gamut of services, supporting services like discovery, coordination, you'll have to have external country. So all of that has to be deployed upfront for your developers to even do development, right? And that's a big overhead when you're doing startups, because your core focus is being able to churn out features, respond to market, and then pivot, and then kind of ensure that people like your product. So so microservices will add overhead there rather than be of your help. The only use case where I found microservices as a good starting point when you want to do microservices is typically when you're doing a monolith rewrite. Yes, you know what it's about. You have all the business models. At least you know the business context. They might be tightly coupled now, but you have clear idea in your head as to what my business boundaries are. What the seams are, where can I cut it. The other thing, if you think that you already know that I'll have scaling issues, I'll have that going forward, then yes, you should start with microservices, but only if you know your domain really well. If you think that your business domain and context is going to evolve over a period of time, it's always better off to start writing with a well-defined monolith that has business modules that are like loosely coupled from an API perspective. So when you get to a stage wherein you think, oh, now I'm really getting to a stage where I think I can't develop this as a monolith, I want different teams to kind of work on this parallel, and it's easier for us to split that monolith along the seam and then move it to microservices. But if you start early, you sacrifice your agility and the ability to respond to your users quickly over your scalability issues that you think will come up later.
So, and those are very good points, Anil, but one of the things I also want to point out is that if you already know that you have subsystems, you may not implement them really as microservices, but there's nothing preventing you from really implementing them as different applications. So
right, I mean that's the use case that you see here. We knew upfront that they are different products, but they eventually might have common services. So over here, we use microservices to glue our stuff together and provide a common infrastructure, monitoring, and rest of the services, but we developed those products as monoliths to start off with.
Right. And that being said, even within these subsystems you may have identified, there is an opportunity to further break them into microservices, and that insight will only come once those applications have actually hit the real world, and you kind of get a better sense of how they are useful, what value they're creating, how much of specific functionality of that application being used by how many people. And that's where this landscape of differential scaling comes in, where you say, look, if people log in only once, but they have, in each session 10,000 transactions to run, that probably makes sense to not scale up the login function as much as the transaction processing function. So, quick question, and again, coming from our audience here, is if you could talk a little bit about microservices and master data management. In the context of microservices, how do you ensure that there are not duplicates getting introduced? How do you resolve this system of records idea with microservices? And I think there's another element of it, which is around, when you have a single system of record and all these things are hitting it, there still has to be a way to scale even that single system of record. So talk a little bit about managing master data and avoiding duplication.
Okay. So, I mean, it again kind of goes to the crux of saying that you'll have one service that basically does that well. So let's assume in this case we have a master data management service, right? that owns that master data and provides a data API that basically lets you do basic CRUD, lets you query on that master data and get it back. So let's assume different parts of your system consume that data and they might update your master data, right? So in this scenario, you could either kind of you could have you can follow the pattern of CQRS and event sourcing. That's kind of that's something that's now at the core of reactive microservices. So CQRS is common query responsibility segregation. So what we're saying is basically for your master data, you could have a system of records where your reads are on the latest data, right? So you could maintain a set of data that basically gives you the latest master data, and then your writes can happen kind of asynchronously, or they can happen separately. So each system that needs to, let's say, update your master data can send a request to your master data management service, which can then take it and then kind of apply an event to say, okay, my master data has changed, and also change the current master data. So that way your master data would still need to be kind of managed by each by a single service that is responsible for it. It takes care of all the CRUD operation and then makes that data available to all the rest of the services that need that master data. So that's how I've seen that the master data management being realized in the microservices world.
All right, so just a quick time check. We have about maybe 10 more minutes or 14 more minutes left in the call. So I just want to make sure, Anil, you have an opportunity to sort of wrap up your presentation, and
Right.
And any more questions as they come in, then we'll sort of answer them in the remaining time.
Right, cool, awesome. So I think we've in course of answering, we've covered some of the points that I make in the presentation. So we'll probably go faster there. Okay. So the key takeaways that we had from implementing this set of microservices was that we start with the monolith first design. At least version 1.x of your system generally is a monolith. We shouldn't even consider microservice unless your system is really complex, because it comes with a premium of managing a suite of distributed services. Our systems change as we kind of discover more system complexity and business component boundaries evolve. So we should kind of go with the version 1.x. So that's what even Martin Fowler says. If you go to his website, he says that almost all the successful microservices that he's looked into have started with a monolith that got too big and was broken up. And almost all the cases where he's heard of a system that was built as a microservice from start kind of ended up in serious trouble. So we need to kind of be cognizant of the fact that in the real world things evolve. As they evolve, we kind of we understand more what are the different boundaries, how they interact with each other. So for me, for me, I've seen that monolith first made sense in this specific case, and the only two cases where I saw that, where I think that I would recommend microservices first is obviously when you do a rewrite of a monolith. That's a given. The other thing is, if you know your domain really well and you think you will have scalability issues right from the start, then yes, go with microservices. Then it's worth it. Otherwise, try with the monolith first, and then when you have a monolith, the next point kind of says is when you design a monolith, you should have a well-designed monolith. If you can't create a well-designed monolith, microservices are not going to be your answer, because it's going to have the same problem as your monolith will have, right? So you should follow domain-driven design principles. You should have services with well-defined seams that you can basically cut and then move into different services. We should peel off microservices once complexity and scaling needs affect productivity and innovation. When your productivity and innovation kind of start suffering because of the time you take your products to release, that's when you should start looking into microservices. The other thing that I typically haven't seen companies that do microservices is to invest in product management and QA. Microservices, any distributed system is inherently difficult to test. It's difficult to kind of then define what different components go there. So please invest in product management and QA. Those are essential to get your microservices ready and then be solid when they are deployed. The other thing that we realized was that containers and orchestration works really well with microservices because by definition microservices are about isolation, being able to isolate your business functionality. So containers provide you that process orchestration. You can, when you package your services as containers, you can run them on any platform. You're not tied to a specific operating system or a specific version of the operating system. Container orchestration gives you monitoring and then failover auto scaling. So if stuff fails, it can be restarted. So so if you look at any orchestration platform like Kubernetes, Swarm, or Rancher, they provide a lot of benefits. If you're deploying microservices, that were the key takeaways. Let's look at the best practices and gotcha. So I think we've covered most of them. I'm just going to list them, and if there are any questions, we'll try to answer them. So the first thing is you need upfront planning and decomposition of business services. When you are trying to do microservices, that's the first and foremost thing. You have to look at our business context and then decompose that into different services. So otherwise you will end up with a spaghetti architecture. The next thing to do is we should avoid distributed monolith. So things that change at the same time should be in the same service. So if at any point of time you find that, oh, if I need to change, let's say, order, and that needs also change to the way I do fulfillment, probably that's something you need to start looking into, to say, is there a common pattern, is there a common component in them, in both of them, that I really need to move to a different service. So that's something that's critical. If you have services that kind of change together, then we are essentially going to the route of a distributed monolith and not microservices. The next point is monitoring microservices is orders of magnitude harder. It's when we actually went to production, it's much harder to kind of visualize what's working well, what's not, where do I need to kind of focus kind of way. So invest time in doing deployment maps and health status of each microservices so that you know when something is down, and then you can take your DevOps can take corrective action to fix that. We need centralized logging, alerting, and distributed tracing. If you have issues in the service, it's in a distributed system, it's very hard to kind of pinpoint the root cause quickly. So unless you have these components built with your microservice, it would be very hard for you to debug and resolve production issues. The other point that obviously Ashish also brought up was, how do we kind of ensure that even if one component of your system goes down, one service goes down, you don't have a catastrophic failure. So if you've looked into ships, the way kind of ships do this same thing is they do what is called as bulkheading. So a ship is divided into a number of components, and then each component is sealed watertight. So if one of them kind of gets flooded with water, the ship doesn't sink. So it's similar principle. So we use what is called as circuit breakers to prevent chain of failures. If service A fails and it's calling service B, or someone else is calling service A, then let's say service C kind of goes to a fallback behavior if service A is unable. So you'll have to have circuit breakers to prevent that chain of failure. The other thing that kind of comes with the being able to debug issues in production is that your issue in service A could be because of input from service B or a messaging queue that kind of passes that message around. So you have to invest in APM tools and strong service contracts to isolate the root cause, as to being able to go to the root cause quickly. We also have to look at the services graph, how each services depend on one another, and then build that into your CI/CD pipeline so that you are able to kind of say that, oh, my distribution today requires version X, Y, and Z of different services. So you have to invest in kind of creating that service graph and then being able to manage that. The other thing that I noticed is that People generally get excited when they say that, oh, now I could solve my problem with a different technology, this new cool stuff that's on the block, right? But over a period of time, it becomes difficult if you have a lot of fragmented technology choices that you make. It makes you harder for you to kind of support it if somebody from that team leaves. So we would suggest that you have some governance on that, you streamline tools and methodology so that most of your teams follow it. If for an outlier cases wherein you would say that, okay, you generally follow a Java stack, let's say for almost all your services, but there's an outlier case where you have event sourcing and let's say where Node.js is a more compelling choice, by all means do that, but try to streamline your tools and methodology as much as you can. The other thing is because all the services now communicate with each other through API, we need to kind of look at their security and track what service API gets exposed and how they are secured. The last problem that we've seen very frequently is how do we ensure that that the services are compatible with each other. They understand what the data that they're communicating. So you should look at consumer-driven contracts for robust API. What it means in a nutshell is that the consumer kind of has a contract that it thinks that the producer sends, that the producer would provide, and it can share that its definition of the contract with the producer. And anytime the producer has to validate that it's the correct contract, and so now anytime your producer changes the contract, your common stuff would fail, and then the teams can communicate across each other and make those changes. So there's a good set of tools called Pact, and there's a Java implementation called PactJM. You should definitely take a look into that to ensure that your APIs are compatible and they work well together. So that's kind of what we should look out when we are doing microservices. So I'll just kind of sum up what we think is what microservices offer. What's the future? So microservices, what we found out, are allowed both by developers and by business. So developers love it for all the cool things that it gives and the productivity it offers. Business loves it for because it enables them to kind of be able to push out changes much quicker to market, get feedback, and then do this very rapidly. So they do it really. It's loved both by developers and business. It has high initial costs because inherently, kind of like I said, doing any distributed system is complex. But if it's done right, the results are worth it. Most of the large enterprises, large companies that we admire have already embraced or are moving to microservices. Netflix, Amazon, Guild, eBay are some of the prime examples that do that. And then our advice to startups who start off is that you start with a monolith and you move to microservices when scaling and agility issues surface. That's it. So like Ashish said, we'll take questions at the end.
So, so Anil, I know we have only about 2 minutes, but and I'll encourage our audience to continue sending us questions. If we are unable to cover them, we will certainly, get back to you with as a follow-up. But questions are more around, the complexity and ability to, address more complex systems. So, for example, ERP systems, do you think they are amenable to being broken up into a microservices type of architecture, and whether that's sort of worth the effort at all?
Like I said, it always is a toss-up between pros and cons. So any system, as long as it has clearly defined business boundaries, could be split into microservices. So Netflix has done that with, like, I think 200 and a number of. It's like if you look at their deployment map, it's like mind-boggling. That's something that Amazon also has done. So almost any system that has been built in, that has a well-defined business context around that, can be broken up into microservices. Like I said, we have to take a hard look into the pros and cons and then and then be able to say, oh, how do we start off? So typically, if you start off by chipping your services, it gives you a much better idea of how it's amenable to microservices. So if you think you're kind of running into a classic monolith problem, we should take a look into that monolith and see if there are services that can be chipped out, and then try kind of building a microservice ecosystem from that. I think that will give us a very good idea of how amenable it is to that, and then it also gives you a data point to start off. Okay, now I think this makes sense to me. How do I now kind of, you could just do a whole rewrite at that point of time once you think it's amenable and you like what you see.
Yeah, and you know, another aspect of it is that it also becomes a question of where that ERP is. So you know, for in-cloud systems, the ERP developer would have much more control on the production environment. So if you look at SAP HANA, for example, they are actually taking the microservices path. But for systems that are on-premise, that's a much harder play, because the microservices sort of imply a certain distributed network and hardware and so on. And often that's harder to justify on an on-prem type of scenario. So unfortunately, we are out of time. I do see a whole bunch of other questions that I promised to follow up with everybody, just to make sure you know, we account for any of these follow-up questions or requests. And thanks a lot, everybody, for joining. And I look forward to seeing you guys next in our next webinar, which is on botnet. Preventing botnet attacks, and I believe the date for it is 15th February, and the link to register is already up. So you're welcome to you know, get in there as early as you can. Thanks a lot for joining, and with that, that's the end of our webinar. Thank you.
Thanks everybody for joining.